1. What is system? Answer: a system is a set of rules, an arrangement of things, or a group of related things that work toward a common goal. Example: laws and procedures of a democratic government. Characteristics of a system. 1. Organization. Organization implies structure and order. 2. Interaction. Interaction refers to the manner in which each component function with other component of the system. 3. Interdependence. Interdependence means that parts of the organization or the computer system depends on one another. 4. Integration. Integration is concerned with how a system is tied together. V. Central objective. All the components work together to achieve that particular objective. 2. What is information system? Answer: an organization system for all collection, organization, storage, and communication of information is known as information system. Decision structure: unstructured, semi-structured, strategic management, information system, decision support system, tactical management, structured operational management, management information system, transaction processing system. 1. Transaction processing system, TPS. TPS are mostly used for record keeping, which is daily routine transactions necessary to conduct business. Objective: to provide transactions necessary to conduct business. Example: bill system, stock control system, payroll system. 2. Management information system, MIS. MIS designed to take relatively raw data available through a TPS and converted them into summarized, aggregated from for the manager. Objective: summary report, on-demand report. Example: sales management system, human resources management system. 3. Decision supported system, DSS. DSS support decision-making process of manager. Example: financial planning system, bank loan management system. 4. Office management system, OMS. OMS is collection of communication technology computers, person to perform official task. It involved in word processing, spreadsheets, database, presentation graphic, web page, etc. 5. Stakeholders information system, SIS. Any person who is interested in an existing or proposed information system is known as stakeholder information system. Example: system owner, system users, internal system users, clerical and service workers, technical and professional staffs, supervisors, middle managers and executive managers, external system user, customers, suppliers, partners, employees, outsourced, system designers, database administrators, network architects, web architects, graphics artists, security experts, technology specialists, network architects. 6. Expert system. 7. Operational management system. 8. Strategic management. 3. What is system development life cycle? Answer: system software development life cycle is systematic process of developing any system software. It is the step-by-step process where each stage is a building block of an effective and efficient program. Types of system. 1. System study. The system study is done in 2 phases. In first phase, the preliminary survey of the system is done, which helps in identifying the scope of the system, and in second phase more detailed of identification of the user requirement, limitations, and problem of present system. 2. Feasibility study. A feasibility study is defined as an evaluation or analysis of the potential impact of a proposed project or program. Types of feasibility. 1. Economic feasibility, cost-benefit analysis. 2. Technical feasibility, risk assessment and solution. 3. Schedule feasibility, timeline estimations and optimization resources. 4. Operational feasibility, control efficiency and services. 5. Cultural feasibility. 6. Legal ethical feasibility. 7. Marketing feasibility. 8. Real estate feasibility. 3. System analysis. System analysis is a person who is involved in analyzing, designing, implementing, and evaluating computer-based information system, CBIS, to support decision-making operation of an organization. Roles and responsibility of system analysis are: 1. Defining requirement. 2. Prioritizing requirement. 3. Gathering data, fact, and opinion of user. 4. Analysis and evaluation. 5. Solving problem. 6. Drawing up specification. 7. Designing system. 4. System design. It is process of defining the architecture, components, modules, interfaces, and data for a system to satisfy specified requirements. There are 2 stages. 1. First stage, preliminary or general design equals the cost implementing and benefits feature is estimate. 2. Second stage, structured or detailed design equals input, output, data. Debugger to generate and implement the code. 6. System testing. Once the software is complete and it's deployed in the testing environment. This is done to verify that the entire application works according to customer requirement. Types of system testing. 1. Black box testing. Internal code of the program are tested. 2. White box testing. The code is totally visible to the general users and they can also make test case. 7. System implementation. In this phase, how to execute the package, how to enter the data, how to process the data, how to take out the report are loaded onto system the user's computer. The following strategic are: 1. Pilot approach, launched new system from only one group within the business. 2. Parallel approach, both systems are operated side by side until new system proved itself. 3. Phased incremental approach, user start the new system component. 8. System maintenances support, correcting and upgrading process of the system is called system maintains. Types of system maintains. 1. Corrective maintenance. Corrective maintenance deals with the repair of defects found in day-to-day system functions. 2. Adaptive maintenance. This includes modifications applied to keep the software product up to date. 3. Perfective maintenance. This includes modifications done in order to keep the software usable over a long period of time. 4. Preventive maintenance. Modifications to prevent future problems of software. It comprises documentation updating, code optimization and code restructuring. 4. What are the different models? Answer: the different types of models are: 1. The waterfall model. Application definition is stable. The requirements are well known, clear and understood. Requirements should not have any ambiguous. The project is smaller. It contains requirements, analysis, design, implementation, testing, deployed, maintain. Waterfall model. Advantages. In this model each stage are clearly defined. This model is simple and easy to understand and use. In this model execution happens sequentially. In this model phases are executed and completed one at a time and phases do not overlap. Waterfall model suits well for projects where requirements are well understood and for shorter projects. In this model each phase process and results are documented. 2. Spiral SDLC model equals spiral model is a combination of the iterative and waterfall SDLC models with a significant accent on the risk analysis. Whenever there is long-term project then spiral model is useful. Whenever user are not sure about their requirements. When it is new product line. if project is mission critical. For medium to high risk projects. Planning evaluation, customer evaluation, risk analysis, engineering, gesting, FIG. The spiral model. Use cases for the spiral model. The customer isn't sure about the requirements. Significant edits are expected during the software development lifecycle. Risk management is highly essential for the project. 3. Prototype model. Whenever the customer not clear about the requirement in this situation, we generally go for prototype model. If it is complex project, then prototype model makes clear understand the requirement. Prototyping makes sure that the customer constantly work with the system and provide a feedback about the system. FIG. Prototype model requirement gathering, prototype development, quick decision, refine requirement incorporation, customer suggestion, build prototype, customer evaluation of prototype, acceptance by customer, iterative design, development, implementation, testing, maintenance. Advantages of prototype model. Customer satisfaction exists because customer can feel the product at very early stage. If there is missing functionality, can be identified easily. There will be less chance of software rejection. Requirement changes are allowed. Due to customer approval, we can find the errors at early stage. Customer involvement will be there in the development, where it leads to better solutions for any confusion, complexity, difficult functions. The developed prototype can be reused by developer and test engineer. Steps in prototyping SDLC models. A preliminary project plan is developed. A partial high-level paper model is created. The model is a source for a partial requirements specification. A prototype is built with basic and critical attributes. The designer builds the database, user interfaces, and algorithmic functions. The designer demonstrates the prototype, the user evaluates for problems and suggests improvements. This loop continues until the user is satisfied. 5. What is the Software Requirements Specification, SRS? Answer. A Software Requirements Specification, SRS, is a document explaining how and what the software system will do. It defines the features and functionality that the product requires to satisfy all stakeholders, business, users, needs. A standard SRS includes a goal purpose, a summary of the whole process, specific requirements. SRS documents contain 3 kinds of program requirements. Functional specifications, that include measures to be performed by the system. Non-functional requirements, determining the software system's performance attributes. Domain requirements, that are device limits on the service domain. Software requirements specifications, quality, safety, BMC, functional specification, performance, interface types, reliability, maintainability. 6. Explain formal technical review. Answer. A formal technical review, FTR, is a software quality control activity performed by software engineers and others. The objectives of an FTR are: 1. To uncover errors in function, logic, or implementation for any representation of the software. 2. To verify that the software under review meets its requirements. 3. To ensure that the software has been represented according to predefined standards. 4. To achieve software that is developed in a uniform manner. 5. To make projects more manageable. Steps in FTR. 1. The review meeting. 2. Review reporting and record keeping. 3. Review guidelines. 7. Define coupling and cohesion. What is the difference between cohesion and coupling? Answer. Cohesion. A cohesive module performs a single task, requiring little interaction with other components. Coupling. A coupling is an indication of the relative interdependence among modules. Difference between cohesion and coupling. Cohesion. Coupling. Cohesion is the indication of the relationship within module. Coupling is the indication of the relationships between modules. Cohesion shows the module's relative functional strength. Coupling shows the relative independence among the modules. Cohesion is intra-module concept. Coupling is inter-module concept. Cohesion. While designing, you should strive for high cohesion, i.e. a cohesive component module focus on a single task. Coupling. While designing, you should strive for low coupling, i.e. dependency between modules should be less. Cohesion is the kind of natural extension of data hiding, for example, class having all members visible with a package having default visibility. Coupling, making private fields, private methods, and non-public classes provides loose coupling. 8. Write a short note on CASE. Answer. A CASE, computer-aided software engineering, tool is a generic term used to denote any form of automated support for software engineering. A CASE tool means any tool used to automate some activity associated with software development. Components of CASE. 1. CASE repository. Central component of any CASE tool. Centralized database. Allows easy sharing of information between tools and SDLC activities. Used to store graphical diagrams and prototype forms and reports during analysis and design workflows. 2. Diagramming tools. Allow you to represent a system and its components visually. Allows higher level processes to be easily decomposed. Can examine processes or data models at high or low level. 3. Screen and report generators. Used to create, modify, and test prototypes of computer displays and reports. Identify which data items to display or collect for each screen or report. 4. Analysis tools. Generate reports that help identify possible inconsistencies, redundancies, and omissions, deficiency. Diagram completeness and consistency. Data structures and usage. Analysis tool, drawing tool, document generator, error checking tool, design generator, case repository, code generator, database generator, security and version control, prototyping tool, screen and report generator. 9. What quality assurance system? Answer. A quality assurance system is composed of multiple elements such as analysis and assessment planning, assessment policies and procedures, and data tools and human resources. Analysis and assessment planning, quality assurance system, data tools and human resources, assessment policies and procedures. Several strategies can be used to assist with designing a comprehensive quality assurance system. These include: 1. Conduct a high-level needs analysis. 2. Complete an assessment audit. 3. Identify and implement data tools. 4. Develop assessment policies and procedures. 5. Discuss results and engage stakeholders throughout the process. Discuss results, identify and implement data tools. Discuss results, conduct high-level needs analysis, quality assurance system, develop assessment policies and procedures. Discuss results, complete assessment audit. Discuss results. The list of SQA activities. 1. Creating an SQA management plan. 2. Setting the checkpoints. 3. Apply software engineering techniques. 4. Executing formal technical reviews. 5. Having a multi-testing strategy. 6. Enforcing process adherence. 10. What is description of the database normalization basics? Answer. Normalization is the process of organizing data in a database. This includes creating tables and establishing relationships between those tables according to rules designed both to protect the data and to make the database more flexible by eliminating redundancy and inconsistent dependency.